Good afternoon, class. In today's video, what I wanted to do was to go over the laws of exponents. So in this video, I'm basically following along with the very beginning notes for quarter one. So if you want to follow along using that, you can. I color coded it just so that it was a little bit easier to see. But so I tried to keep it as colorful as I could. So here we go. The laws of exponents, and I give an example with each one of them. So hopefully that helps you to see how the laws of exponents can be applied. I tried to keep it as in the simplest way that I could. Even though some of these examples look kind of long, what I'm going to try to do is appeal to you to how the breakdown of all of the different ways of applying these laws, so that you can see through multiple means, even if it's one example, multiple means of how to get the same answer. So let's start with law number one. Law number one says x to the mth power times x to the nth power is equal to x to the m plus n. So basically, it's saying that if the bases are the same, like they're both the same base x, and they're raised to different powers, if you're multiplying them together, you add the bases. You add the exponents. So we see that in this example. Let's say m was 2 and n was 3. So I've got x squared times x cubed, which I could write out, because x squared is just x times x. I could also write x cubed out as x times x times x. So notice that there are 1, 2, 3, 4, 5 x's. And they're all being multiplied together, so that would be the same thing as saying x to the 5th power. Now, of course, I could also get that by saying, oh, 2 plus 3 is 5. So that's how I got that answer. Now let's move on to law number 2. Law number 2 states that x to the m divided by x to the n, which is also written in this form as a fraction, is equal to x to the m minus n. So if they're being divided, you subtract the first exponent from the second exponent. My example in this one is x to the 3rd divided by x squared. So what I've got is I've got this fraction, and I put x times x times x in the top for x cubed, and fraction bar, and then in the denominator, x times x for x squared. And as you can see, I've got x over x, x over x. And as we can recall, doing a simple drill, 2 divided by 2 is 1, 3 divided by 3 is 1. So therefore, x divided by x must also be 1. So that's why I've been able to cancel them out. And all that I'm left with at the end is just x. X to the 1st power. I could also rewrite that as x to the 3 minus 2, which is equal to x to the 1st, or I could just write it as x. So that would be law number 2. Let's go to law number 3. In law number 3, I say that x to the mth power, raise all of that to the nth power, is the same thing as saying x to the m times n power. So in my example, I would say x squared raised to the 3rd power would be the same thing as saying x times x raised to the 3rd, which is also x times x times x times x times x times x. And so if you look at this, that's 6 x's, so that would be x to the 6th power, which is also 2 times 3. So that's an easy way to remember that. Okay, now let's go on to law number 4. This one is a little bit tricky, so stay with me on this one. But here we go. If I've got x raised to the mth power, and I take the nth root of it, that would be the same thing as saying x to the m divided by nth power. So basically, if you take a root of it, whether it's the cube root, the square root, the 4th root, it doesn't matter. That root is going to be in the denominator of your fractional exponent, basically. So now I could just show you some examples and just say and appeal to the law itself and say, oh, there it is. But what I thought I'd do is I would appeal to one of the rules that we are already familiar with, which is to take square roots of different values. So for my example, I took the square root of x to the 4th power. Now, this 2 over here, I wrote that just to show you that's what the root is. It's not necessary, because if you don't write anything, it is assumed that you are talking about the second root or the square root of anything when you have the radical sign over here. So x to the 4th, based on our first law, can also be written as x squared times x squared. Now what I hope you notice is, based on your training on square roots, like if I have the square root of 9, because 9 can be written as 3 times 3, and I've got 2 of those 3's, what I can do is they basically are able to break out of the radical, and it would be simplified to just 3. Okay, so in this case I've got x squared times x squared. Oh, I've got a square of x squared. So that means this x squared is actually able to break out, and it turns into just x squared at the end, which is also the same as 4 divided by 2, which is 2, and there you go, x squared. One of the things, I'll pause and do a little bit of a way that I'll introduce the way that I like to think about radicals. Hopefully this helps. If it doesn't, again, don't worry about this. If it doesn't help, if it helps you, great. If this doesn't help you visualize or at least picture mentally how to think about square roots or taking any kind of root itself, then you can figure out your own method. But this is the way that I like to think about it. I like to think about square roots or any kind of roots or any radical signs that you put onto any kind of function. I like to think of that as kind of like a jail, and there is a way to break out of that jail, and the way to do that is if the occupants of this jail can combine their powers, but only if they're of the same type. So if you have like x to the 4th and y, the y will never break out because it doesn't have enough power to get out. The condition for, the amount of power that's needed to break out is given by the root over here, which is in this case a 2. So x to the 4th, which is, what it's telling you is that you need a square, or you need 2 sets of something of this base x to get out. So the minimum requirement is x squared, because x squared has 2 x's. They can combine their powers and break out of the jail. If it was the cube root, then you would need 3 x's to combine their powers through multiplication and break out. So in this case, I've got x squared times x squared, and it's a square root. So I can break down x to the 4th as x squared times x squared. You've now got a group of 2. They can combine their powers through multiplication and break out of this square root jail that allows them to become just x squared, right? Because they've combined their powers. So hopefully that kind of helps bridge the gap between how to handle radicals or radical signs, roots, and how it connects to fractional exponents. Let's go on now to the very last bit of the laws of exponents, the 5th law, and that law is x to the negative nth power is equal to 1 over x to the n. And the way I thought I'd show this is I could just have appealed to the law itself and said, it is a definition, here you go. But I thought what I'd do is I would use law number 2 over here to show you why this law actually exists. So my example this time, instead of it being x cubed divided by x squared, it's going to be x squared divided by x cubed. And so again, I'd show my multiple methods. X squared is x times x, divided by, so that's where the fraction bar comes from. X cubed is x times x times x. So what I can do, and like we did in this earlier part, I have x divided by x, which is equal to 1. And so I've gotten rid of a few of these x over x's, and all I'm left with is 1 over x at the end of all of that. However, if I appeal to law number 2 here, what that means is that this is the same thing as x to the 2 minus 3, because of law number 2. So that would be, and 2 minus 3 is negative 1. But we also know that this result, 1 over x, is also true, so that's why x to the negative 1 is equal to 1 over x. So that concludes what the laws of exponents are and some of their examples that go along with them. After this, of course, is the review questions that go with this. So good luck in your studies, and may the force be with you.